AMC 8 2022 American Mathematics Competitions. We want to solve all problems of this year 2022 AMC 8. For having next videos, subscribe my YouTube channel now and turn on the bell and like my video. Problem number 1. The math team designed a logo shaped like a multiplication symbol, shown below on a grid of 1-inch squares. What's the area of the logo in square inches? Okay, if we calculate, we have 1, 2, 3, 4, 4 square plus. Each of them is 1 times 1 over 2, half of a square or a triangle, right angle triangle with side length 1. 1 times 1 over 2, 1/2. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Plus 12 times half. It will be 4 plus 6, 10. So the answer is A. Problem number 2, we have these two equations. What's the value of this? So 5 diamond 3 is what? 5 squared minus 3 squared, which is what? 25 minus 1, 16. 16 star 6, which will be 16 minus 6 squared, which is 10 squared, 100. The answer is D. Problem number 3. When three positive integers a, b, c are multiplied together, their product is 100. Suppose a is less than b less than c. In how many ways can the numbers be chosen? So 100 is what? If we prime factorize, it will be 2 squared times 5 squared. A, b times c is 100. So we consider on C the cases of C. If C is 100, then it is bad because we have 1, 1, and that's bad. Because A less than B. If A is 50, the product of AB is 2, so B should be 2, A 1. If C, how many positive divisors does this number have? 1, 2, 4, 5, 10, 20, 25, 50, 100. And the number of them is 9 because 2 plus 1 times 2 plus 1, 3 times 3, 9. The formula is this. If you had any question, there are some formulas, basic formulas you should know. If you want to know them, as I said before, feel free to send a message to my WhatsApp number in the description and comments. So 1, 2, 50, and then 25. The product of them will be 4. It can be 4, 1, 2, 2 is impossible. So we've calculated this, calculated this, 20. The product of them will be 5 and 1 case, 10. The product of them will be 10, but it shouldn't be 10. 5 to the only possible case. If it is 5, then the product of them will be 20. If both of them are less than 5, at most 4. 4 times 4, 16. Contradiction from here. We don't have any other answers. So how many answers do we have? 1, 2, 3, 4. So the answer is E. Problem number 4. The letter M in the figure below is first reflected. So let's show it. First reflected over the line Q. So it will be something like this. Look, this axis, y-axis, will be changed to x-axis. Vertical to horizontal like this. And then reflected over the line P. So it will be something like this. What's the resulting image? So it will be, no. Okay, it is exactly this. So the answer is E. Problem number 5. Anna and Bella are celebrating their birthdays together. 5 years ago when Bella turned 6 years old. So suppose that Bella now is B. So 5 years ago, B minus 5. When Bella turned 6 years ago, she was 6. So Bella is 11 years old now. And she received a newborn kitten as a birthday present. So if we consider kitten K, 5 years ago, newborn, so now kitten is 5. Today, the sum of the ages of two children means B plus A plus and the kitten. K equals 30. How many years older than Bella is Anna? So K is 5, B is 11. 11 plus 5, 16, so A is 14. Bella is older than, how many years older than Bella is Anna? So Anna, 14 minus 11, 3. So the answer is C. Problem number 6. Three positive integers are equally spaced on a number line. The middle number is 15. So let me draw this. We have 15 and equally spaced. So for example, it is 15 plus A, 15 minus A, and all of them are positive integers. And the largest number is 4 times the smallest number. Largest number is 15 plus A, 4 times the smallest number, 15 minus A, which equals 16 minus 4A. So we take negative 4A to left hand side. 4A plus A, 5A, 60. Take 15 to right hand side. 16 minus 15 will be 45, which then we've got A equals 45 over 5, which is 9. The problem says what's the smallest of these three numbers? So 15, smallest one. 15 minus A, which is 15 minus 9, 6. So the answer is C. Problem number 7. When the World Wide Web first became popular in the 1990s, download speeds reached a maximum of about 56 kilobits per second. Approximately how many minutes would the download of a 4.2 megabyte song have taken at that speed? Note that there are 8,000 kilobits in a megabyte. Okay, we say 4.2 megabyte, and each megabyte has 8,000 kilobits. So it is the size in kilobits. If we divide by 56, then we find the number of seconds. And because it says the number of minutes, you should divide by 60. So it will be what? It will be 42 times 800 over 56 times 60. We divide 0 here. 56 by 8, 7. Here by 8, 10. Here 6, it will be 7. And this part. So the answer is 10 minutes is B. Problem number 8. What is the value of this product? You say, okay, 3 will be cancelled. It is telescoping product or telescoping rule. It will be cancelled all of them. So we have what? 2 over 21 times 22. We divide by 2, it is this. 11 times 21 will be 21. 231, so the answer is 1 over 231. The answer is B. Problem number 9, a cup of boiling water. Okay, a cup of boiling water, 212 Fahrenheit, is placed to cool in a room whose temperature remains constant, okay, at 68 Fahrenheit. Suppose the difference between the water temperature and the room temperature is halved every 5 minutes. What's the water temperature in degrees Fahrenheit after 15 minutes? Okay. So in each 5 minutes, so we have 3 steps. First 5 minutes, second and third 5 minutes, because we have 15 5 minutes. The temperature of cup of boiling water is 212 and it is 68. And the problem says their difference will be halved every 5 minutes. So their difference at first is what? 212 minus 68, 12 minus 8, 4, 0, 10 minus 6, 4, 1 minus 0, 1. So the difference is 144. In first step, 72 divided by 2, 36. And after 15 minutes, it will be 18. It says the temperature of room remains constant at 68. So when it is 68, so you say 68, the difference is 18 plus 18, and look, the temperature of boiling water is decreasing, and it will be until 18 more than 68. So it will be 78, 86. So the answer is B. Problem number 10. One sunny day, Ling decided to take a hike in the mountains. She left her house at 8 a.m., drove at a constant speed of 45 miles per hour, and arrived at the hiking trail at 10 a.m. After hiking for 3 hours, Ling drove home at a constant speed of 60 miles per hour. Which of the following graphs best illustrates the distance between Ling's car and her house over the course of her trip? Okay, so the first part here, 8 a.m. start 8 a.m. drove at a constant speed of 45 miles per hour and arrived at a hiking trail at 10 a.m. So for 2 hours, and 2 times 45 is 90. So from 0 he should reach 90. So the first part here is correct. Here is wrong. This is wrong. This one is also 0, 90. This one is also wrong. So if we consider E is also okay, we can't reject it. So 2 cases are left. Now let's consider the second part. After hiking for 3 hours, so 3 hours, 1, 2, 3, we can't reject A. Also we have E here, 3 hours, we can't reject E. So we should consider third part. Okay, in third part it says Ling drove home at a constant speed of 60 miles per hour. So because we have 90, from 90 you want to reach 0, 16 miles. So after you say, okay, 90 over 60, the speed, 1 hour and a half. So after 1 hour and a half, 1.5 times 60 will be 90. So here we will be after 2 hours. So the speed here is again 45. So we reject A. If we check E, we will see that here 1 hour and a half. And that's okay, exactly the thing that we wanted. So problem number 10, the answer is E. And problem number 11. Henry the donkey has a very long piece of pasta. Okay, long piece of pasta, and he takes a number of bites of pasta each time, eating 3 inches of pasta from the middle of one piece. In the end, he has 10 pieces of pasta whose total length is 17 inches. How long in inches was the piece of pasta he started with? So look, at first, suppose it is like this. Let me show with black. He takes what? He takes a number of bites. Okay. In each case, 3 inches. The length is 3. So look, after, for example, 2 cases, and always in the middle of one piece. So 1, 2, and we can say, okay, 3, for example, from here, because in the middle. 3, for example, from here. It's better to show it a little smaller. 3 inches, and for example, 3 inches here, if you want 3 inches here. So the first one, he divides to 2 pieces. After, for example, 3, 1, 2, 3, 4. So 4 pieces. In the end, he has 10 pieces, so he has 9. We have 9 these 3. Because after 3 of these intervals, then we have 1, 2, look, 1, 2, 3, 4. So because we have 10 pieces at the end, we had 9 of these 3 inches. So you can say 9 plus times 3 plus, at the end we have 7 inches, the total length. It will be 27 plus 17 equals 27 on. Let me also show you can say, okay, these 3s. This is the first one, it is the second one, and it is the 10th one. So if we count, we have 11 pieces, and the total is 9, is it 17 plus these 9 times 3 length. It will be 30, 44. So the answer is D. Problem number 12. The arrows on the two spinners shown below are spun. Let the number n equal 10 times the number on spinner A. And okay, so let me consider 10A plus added to the number on spinner B. What's the probability that n is a perfect square number? So you say n, if A is 5, then 50, what is perfect square? We don't have any good case. If it is 6, only 64 is good. If it is 7, we don't have any good numbers. If it is 8, we have only one that is good. So we have only 2 good cases over all cases. 4 times 4. And if we divide by 2, it will be 1 over 8. So the answer is B. Problem number 13. How many positive integers can fill the blank in the sentence below? One positive integer is what more than twice another, and the sum of the two numbers is 28. Okay, so consider that a plus b is 28, and one positive integer is more than twice another, and the sum of, okay, so it is, for example, a is greater, and you say, okay, because a is greater, you say, for example, suppose it is a, so it can be what? In the first case, it's, for example, 15, and it is what? So here, if you consider 15, then it will be 13, and if you consider twice, it is not something more than twice, and you should place positive integer. So here, if you consider the numbers, a should be greater than equal to b. And we can say, okay, 28 is a plus b. So, and b is, we can say, for example, b is less than a over 2. A plus a over 2, it will be 3a over 2. If we multiply by 2, it will be 3a over 56, and a is greater than 18 point something. So if we consider, let's check the smallest one at first. A is, for example, 19. Then it will be what? It will be, b will be 9. And okay, 2 times 9, 18. So the answer here will be 1. If we consider 20, it will be what? It will be 8. And because some of them is 28. 2 times 8, 16. The answer here is 4. Here, 21, 7. You can check that. 14, this will be 7. The next one, 22, 6. If I write all of them to show you what are the numbers, 23, 5, 24, 4, 25, 3, 26, 2, 27, 1. Okay, and each of them, it is 22 minus 2 times 6. It will be 10. And you see, these are its arithmetic sequence, and added by 3 each time. It will be 13 if we calculate. And it has risen easily because it is increasing by 1, decreasing by 1. This minus 2 times this will be 1 plus 2. 3 here. 19, 22, and 25. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer is D. Problem number 14. How many ways can the letters in beekeeper be rearranged so that 2 or more E's don't appear together? So for this problem, let's consider letters B, K, P, R, and how many E's do we have? 1, 2, 3, 4, 5. So for the idea of this problem, if they want to be together, all of them, you consider a box. If they are not together, the idea is you permute other letters for factorial and then place between them. We have 1, 2, 3, 4, 5 space because we have exactly 5 E in one case, you should place them in each space exactly 1 so the answer is 4 factorial, which is 24, so the answer is D. Problem 15. Laszlo went online. Okay, Laszlo went online to shop for black pepper and found 30 different black pepper options varying in weight and price. Show in the scatter plot below in ounces what's the weight of pepper that offers the lowest price per ounce. So because we want to find what? We want to find the lowest price per ounce, so we should divide P by W for each of them. So P over W is the gradient of each point, and we want to find lowest. So which of them has, let me show with black, which of them has the lowest gradient. So you consider this with your ruler, you can do this. And the first point it touches is this point. So we understand this thing has the lowest price per ounce and says, okay, in ounces, what's the weight of this? So the weight here is 3 ounces. So the answer is C. Problem 16, 4 numbers are written in a row. The average of the first 2 is 21. The average of the middle, okay, so let's write A, B, C, D. The average of the first 2 is 21, so the sum of them is 42. The average of the middle is 26, so the sum is 52. Why? Because A plus B over 2 is average 21. If we multiply both sides by 2, it will be 42. Similarly, B plus C is 2 times 26, which is 52. And C average of the last 2 is 30, so C plus C is 60. What's the average of the first and last of the numbers? First and last. So we say we consider A plus B minus this minus B plus C plus C plus D. And it will be what? It will be cancelled. It will be cancelled. And it will be A plus D. It was 42 minus 52 plus 60. 42 minus 52 is negative 10. 60 minus 10, which will be 50. And A plus D over 2 is 25, the average. So the answer is B. Problem number 17. If n is an even positive integer, the double factorial notation, this represents the product of all the even integers from 2 to n. For example, 8 double factorial is 2, 4, 6, 8 times. Product of them, what is the units digit of the following sum? So when you have the unit digit, you should consider remainder when divided by 10. The first one is 2, the second one is 2 times 4, the third one is 2, 4, 6, the fourth one 2, 4, 6, 8, the next one 2, 4, 6, 8, 10. From here, all of them have 10, so you can say 10k, so you need to only consider these parts. It is 2, 2 times 4 is 8, 2 times 4, 8 times 6, 48, and 2 times 4, 8, 6 times 8, 48, yes, and you don't need to calculate this, you say 8, only consider one's digit. 8 times 8, 64, you consider only 4. Also here you only consider 8. 8 plus 8, 16 plus 4, 20. 20 is 0 one's digit, so the answer is 2. So the answer is B. Problem 18, the midpoints of the 4 sides of a rectangle are negative 3, 0, 2, 0, 5, 4, and 0, 4. What's the area of the rectangle? Okay, if we consider the midpoints, for example, suppose our rectangle is something like this, for example, any shape. And if we consider midpoints, it will be something like this. And they are perpendicular to each other because when you connect the midpoints, it is perpendicular to each of them. We have 4 rectangles. And so if you consider these 2 midpoints, the gradient here and gradient here, the product of them should be negative 1 because they are perpendicular to each other. If we consider this one and this one, the gradient will be what? 4 minus 0 over 5 minus 3, which will be 5 plus 3, 4 over 8, 1 over 2. If we consider these 2 points, 4 minus 0, 0 minus 2, which will be negative 2. The product of them is negative 1, so we see that they are midpoints of our rectangle, and the area is what? If we consider the area is this times this, for example, if we consider is A is B. A times B. So we should find the distance of these two midpoints times the distance of these two midpoints. The distance of these two midpoints will be 4 minus 0, 16, plus 5 minus 3. It will be 8 squared, 64, times these two things. 4 minus 0, 16, 0 minus 5 plus 25. And if we consider the product, oh, sorry, here the difference is 4, 16 plus 4. So let me correct this part. Here, so it will be, if I want to show it better, if you didn't understand, 4 minus 0 squared plus 5 minus 3 squared. It is the length of, for example, one side, times 4 minus this one and this one. 4 minus 0 squared plus 0 minus 2 squared. And then we've got what? It will be 16 plus 64 times 16 plus 4, which equals 80 times 20. And if we multiply 10 times 10, take it outside. 8 times 2, 16, take it outside. It will be 4. And the answer is 40. So the answer is C. Problem 19. Mr. Ramos gave a test to his class of 20 students. The dot plot below shows the distribution of test scores here. Later, Mr. Ramos discovered that there was a scoring error on one of the questions. He regraded the test, awarding some of the students 5 extra points, which increased the median test score to 85. What's the minimum number of students who received extra points? Note that the median test score equals the average of the two scores in the middle if the 20 students' scores are arranged in increasing order. So here, let's consider the median now. We say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and okay, so suppose that, for example, we have 4. Then 2 here, 2 here, 2 and 3, the average is median. When we have 20, you consider 10 here, 10 here, the 10th and 11, the average of them is median. So here, 4, 8, 9, 10. 10 and 11, 10th and 11th member. So now, before regrading, the median is 80. But after regrading, some of them have 5 extra points, it should be 85. Now here we can say, okay, if these 4 students go like this to next one, then 10th and 11, it will be 85. So the answer is 4 or less than or equal 4. If someone find example less than 4, it means what? It means we have 10th and 11 here or something here plus here. Their average is 85. If you want to have 2 elements here, 10th and 11 in 85, you need to move 4 students. If you want to have something here, then if you move, for example, some of them here and the other ones here, so 1, 2, if you move also, let me show with other colors. If you move it here, then we have at most what? In this place, 1, 2, 3, 4, 5, 6, 7. 7 elements. It is at most 7. So when we have 7 elements, again 10th and 11 are in this part. 10th and 11th. So you can say, okay, because they are here, if the average should be 85, because both of them, 10th and 11th, is less than 85, so both of them should be equal to 85. So you should have 10th and 11 here in this column, so you should move at least 4 students from here to here. So the answer also is at least 4. So the answer is C. Problem number 20, the grid below. The grid below is to be filled with integers in such a way that the sum of the numbers in each row and the sum of the numbers in each column are the same. For 4 numbers are missing. 1, 2, 3, 4. The number x in the lower left corner here is larger than the other 3 missing numbers. What's the smallest possible value of x? Okay. So here you will say what? If we calculate this, -2 plus 97 plus 5, 12. Also if we calculate this, 12. So we understand also this row is 12. So it should be 4 minus x. Also this column should be 12. So it will be 14, 12 minus x. Also this row is 12. So we conclude what? This plus what is 12? 14 minus 1, 13. -1 plus x. This 12 also, if we check here, it will be 12. So now 12 is okay. It says what? X is larger than the other 3 missing. So x is greater than 14 minus x. X is greater than x minus 1, which is obvious. X is greater than 4 minus x. From here, it's equivalent that 2x greater than 4 and x greater than 2. This is equivalent that 2x greater than 14 and equivalent that x is greater than 7. So the minimum possible case is x equals 8. And also when you have these problems, try to check that is it okay or not. So if we draw 3 by 3 table, then we have -2 here, 9 here, 5 here, x is 8. 14 minus 8, 6. 8 minus 1, 7, -1, 8, 4 minus 8, -4, and 8. And we can see all of them is okay. 16 minus 4, 12, this one 12, this one 12. 9 plus 5, 14, minus 2, 12. This one is okay. 14, 12, this one 9, 16, minus 4, 12, and 13 minus 3. All of them are 12, and 8 is greater than 6, greater than 7, greater than -4. Problem 21, Steph scored 15 baskets out of 20 attempts in the first half of a game. So 15, 20, and 10 baskets out of 10 attempts in the second half, 10 over 10. And Candace took 12 attempts in the first half and 18 attempts in the second half. In each half, Steph scored. So let's consider it is, for example, x, it is y. In each half, Steph scored a higher percentage of baskets than Candace. So 15 over 20 is greater than x over 12, and 10 over 10 is greater than 11 over 18. Now, surprisingly, they ended with the same overall percentage. So at the end, it will be what? 25 from 30, 15, 10, and x plus y baskets over how many attempts? 30. It says they are equal, so you understand 25 equals, let me write here, x plus y equals 25 because all of them 30 attempts. How many more baskets did Candace score in the second half than the first? Second half than the first, so y minus x is what? Here, if we simplify, we can multiply both sides by 4, it will be 3, and it will be 5. Here it will be 3, so x is less than 9. If we cross multiply because they are integer, x is at most 8. Here we divide, y is less than 18, so because y is integer, y is less than or equal 70. If we add up these two inequalities, x plus y is less than or equal 25. But we know x and y, the sum of them is 25. So x equals 8, y equals 17. And the answer is 17 minus 8 equals 9. So the answer is C. Problem 22. A bus takes 2 minutes to drive from one stop to the next and waits 1 minute, and each stop to let passengers board. Zia takes 5 minutes to walk from one bus stop to the next as Zia reaches the bus stop. If the bus is at the previous stop or has already left the previous stop, then she will wait for the bus. Otherwise, she will start walking toward the next stop. Suppose the bus and Zia starts at the same time toward the library, with the bus 3 stops behind here. Like first, second, third. So 3 stops behind. 1, 2, 3. After how many minutes will Zia board the bus? Okay, so we know after Zia is here, see this one, and okay. So because bus is not here and also in this place, because it says if the bus is at the previous stop or has already left the previous stop. So here it is not, the bus is not here, so it starts to walk. After 2 minutes, bus reach here also. He is walking, for example, in 5 minutes he reach, it is around here. 1 minute for boarding passengers, and stop after here, 3 minutes here, and then okay, again 2 minutes and 1 minute here. So 2, 1, 2, 1. It is 3, 5, 6. So is here the Zia, and okay, 2 minutes, 1 minute here, 3, it was 1 here, the distance, and plus 3 here, it will be 4. And after, for example, 1 minute, the bus is here and he reached this point, and see, the bus is not here or in this path, so he moves. So here 2 and 1. From 1 here and 1 here, he will reach 2 in this part. And okay, again, after he reached 2 here and 1 in this point, and then it was 2, 2, 1, 3, 5. He reaches this point, and okay, and when he reach here, the bus is in this point, and she waits. So after how many minutes bus reach? 2 minutes. So 2 plus 1, 3, 3, 3, 3, 4 threes, 5 threes. 5 times 3 plus 2, 17. So after 17 minutes, Zia will board the bus. So the answer is A. Problem 23. A triangle or circle is placed in each of the 9 squares in a 3x3 grid. Shown below is a sample configuration with 3 triangles in a line. So like here vertically, or also we should consider horizontally. How many configurations will have 3 triangles in a line and 3 circles in a line? So I consider it is T, and this one is we call C. Okay, so if we consider, for example, we have C, 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 T, 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 consider horizontally only. And we know that for vertically, we multiply by 2 and they don't have any intersection. Because when you have C, 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 you can't have one vertical T, T, T. And also when you have T, 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 horizontally, you can't have C, C, C vertically. So we multiply, let me correct it, we multiply by 2. Okay, so I consider we have exactly 1 CC, 1 TT, and it is not CCC or TTT. So we say what? For CCC we have 3 cases, for TTT we have 2 cases, and this place it will be 2 cubed minus CCC and TTT minus 2. And then we multiply the whole term by 2. Because I said also we should consider vertically. Now if I consider that, for example, we have 2 CC and 1 TTT. So I multiply by 2 because vertical and horizontal. And then I say I have 2 CC or 2 3Ts. Multiply by 2. For example, I have 2 C and 1 T. Like these 2 rows contains C and 1 row contains T. And then I multiply by what? I say, okay, I should select which one is, for example, 2C, 1T, which row is T. So 3 cases. If we calculate, the answer will be what? 3 times 2, 6. It is also 6. 6 times 6, 36. If we factor from 236 plus 6, 42. 2 times 42 is 84. So the answer is D. Number 24, the figure below shows a polygon A, B, C, D, E here, F, G, H, consisting of rectangles and right triangles. When cut out and folded on the dotted lines, the polygon forms a triangular prism. Okay, so if we draw triangular prism, it will be like this, and if you consider the points are like this, if you imagine, suppose that AH equals EF equals 8. AH is 8, so if we consider AH is 8, let me write with the rest of that with green. AH is 8, and EF is also 8. This one is 8, so we understand it is also 8. This one is 8, and this one is 8 because of these 8. And GH is 14. GH. Okay, so let's consider something. Here, GH is 14. If I consider these 8s, so AH is 8. So I consider it is 8. It is 8 like this. And if you consider it is also 8. And this one is also 8 from the problem. Because if you consider, okay, so let's consider this one. GF, look, EF equals, for example, this one ABCB equals IJHJHD, all of them. And here AH is this point and EF is also 8. EF is what is this point? Because it is 8, it is 8, it is 8. So if we apply on this figure, we say, okay, BA is 8, BC is 8. BA is 8 and also BC is 8. And the next one, AI, let's consider first verticals. JI is 8. So here we don't need to show that. JH is 8. It is 8. DIDH. So DI is 8. DH here. Okay, this one, GF, EF. GF is 8. EF is 8. And this one, IA, IC. IA, IC is 8. Okay. And HAHC is 8. And okay, JB 8, DB. Okay. Now we've calculated these things. So it says what is the GH is 14. GH here is 14 means this must be 6, GJ. So GJ, if we consider, it will be 6. Also it will be 6. So if I consider BG this by Pythagoras theorem, it will be 10. FAFC. So it will be 10, it will be 10. Now, what is the volume of the prism? You say, okay, the area times the height. 6 times 8 over 2 times height 8. It will be 4. 4 times 8, 32. 6 times 32. 6 times 2, 12. We have 1. 6 times 3, 8. We lost 18 plus 1, 19. So the answer is 192. So the answer is C. Problem 25. A cricket randomly hops. Okay, a cricket randomly hops between 4 leaves on each turn, hopping to one of the other 3 leaves with equal probability after 4 hops. What's the probability the cricket has returned to leaf where it started? Okay, we calculate all cases and divide good cases over all cases. If we consider all cases, so after 4 hops, in each case, it can go to any of these 3. So it will be what? It will be 3 in each step, 3 times 3 times 3 times 3. 3 to the power of 4. Now, if you want to consider good cases, for example, suppose it is A, it is B, C, D. So It can go after A to one other these things, for example, X, which is B or C or D, or again to A, X, A. One good case is this. One case is A, for example, X, we know X is not A, and in also second step, he won't reach A, so it is Y. Also in third one, this one, it mustn't be A, so, and it is A. And we know X, Y, Z are not A. If we consider the first one, X can be any of these B, C, D, 3, and then again these and these, 3, 3, 9. And if you consider this one, X is 3, so Y is not X, is not A. For example, you go to B, and after that you can't go to A because it is the case that we don't, after, for example, in second step, we don't go again to A. So B can only go to C or D, so 2, for example, you go to C. After that, from C, you can go only to B and D because we want, in this step also, we don't go to A because at the end we want to reach A. So again, 2. In the last step, you reach A, so it is 12. And we divide, we can say, okay, 3 by times 3 plus 3 times 4 over 3 to the 4. It will be, we can cancel this 3 cubed, 3 plus 4, 7. 7 over 27, 3 cubed. So the answer is E.